Hello, this is Old Electronics Fan, and the reason I'm doing this video today is because a guy by the name of Jim Smith um, commented on the video I did regarding how a full wave rectifier works and how it's possible to get a positive voltage from the cathode. And he asked me the question, well, how does that work in a series string radio? And to be honest, I didn't have a good answer. I had some ideas, but I wasn't sure. Now, I spent a lot of time on this trying to sort things out, and it turns out I had the information right in front of me and I missed it. Because I mentioned in that first video about the Navy electronics course, and I actually had one of these, the sheet that I'm about to show you, in that video about the full wave rectifier, and I believe it has the answer for us. And it was the answer that I kind of thought was correct, but unfortunately it's been quite a while since I did that video and I just didn't remember this rather important detail. So, before we go too far, first of all, I'm going to show you this. This is from a tube manual. Actually, this is a PDF that had the had information on the 35W4. So this is the specs for the 35W4, and they give you typical circuits for the 35W4. They show you with the panel lamp and without. And actually there's one other variation that they don't show here, which isn't really all that important, but on one of the radios I own, the AC line comes in to pin 4, which is one side of the filament, and then a resistor comes off from pin 4 and goes up to pin 5. So there's a little bit of variation here, but the key point that we need to notice here is, and you don't even need to worry about this part per se, they're just showing how the filaments are getting powered in these circuits. So it's helpful information, but here's the key point. This is your DC output. This is the B- line. This is the AC line going into your plate, regardless of which one of these two is you're looking at. And of course, now your output is, again, your B-, and then the cathode. Let's look at the circuit that represents the radio that I'm playing with. This is a somewhat simplified diagram that shows the filaments, and this is the radio that has that resistor between pin 4 and pin 5. And it's kind of interesting how they've done it. They're actually feeding the AC line in through the center tap and then through pin 4 of the filament. So you're going through this part of the filament and then that part of the filament and then into the plate. And I originally had this drawn with this just going to ground, and with this being ground, it should have been clear that this was connected together. But to make it clearer, I did that. But I decided that I wanted to go down here and make it even simpler. So this represents the resistance in the line going over from this point over, actually. I just kind of left the filament out of here. So I went down here, I simplified it. There's that little resistor and part of the filament. And then here's the other leg. Now, when I was thinking about this, I was thinking that this was very similar to what I was showing you in the full wave power supply in that video. And in that one I showed you a resistor, a pair of resistors actually. Say this is your minus, say this is your minus voltage here, you have a positive voltage here. If you connect your meter, negative lead here, positive lead here, you're going to read positive volts at this point. Put your negative lead here, your positive lead here, you're going to read positive volts here. So it's interesting how that works when you have multiple resistances. Now, I came to the conclusion that that couldn't be true because, let's look at this. Now I drew some arrows that show the current flowing, and the way, I should probably explain this for people who may not be familiar, and some of you this is old hat and he's like, oh, you're going to start yawning, but bear with me. When, and I'll show you in the page from the electronics training course, when the positive going pulse of the AC of the AC feeding into this hits this plate, this tube will conduct, and then that's this current flowing in this direction. Then when the negative going pulse hits here, all the current stops. Now my conclusion when I was looking at that was that this was behaving pretty much like a resistor. It treated as a load of some kind, and that this was behaving like this. So let's look at this sheet. Alright, now when I first glanced at this, I kind of ignored it because it had the transformer here. But I was wrong to ignore this because it doesn't matter if this transformer is here or not. So here we go. They're showing us that if you have a transformer, you usually have a filament coil on your transformer supplying the filament voltage that you need. With a series string rectifier, obviously there is no filament coil. It's actually part of the supply as I just showed you. So you can ignore the fact that this is here and just remember that this filament is getting fed as part of a series of filaments. But here's the important part of this. They are showing you that this is positive. This is your plate. It must be positive in order for anything to happen, in order for current to flow. They're also showing you that this is minus, and then when you go here, in fact let's go down here. So there's your load, there's your voltage out. Let's go here and they show you they have a minor mistake in their page here. This should be 404 volts, not 425, because you've got 21 volts plus 404, which would equal that. But anyway, we're going to ignore that. So in this case, again, they've got the transformer here. They've got a load resistor. In this case, they're putting it 10 kΩ. I think these are around 500 ohms. They may even mention it in here. By the way, this is page 3.5 of section 6 of the or manual 6 of the Navy training documents. So let's see. Do they tell you this current produces voltage drop tube and load resistor, which have polarities as shown? Okay, plate resistance of the tube is only about 500 ohms. Okay, so your tube actually has an effective internal resistance of around 500 ohms. And then now you have across it, this would be your radio, your amplifier, whatever it is that you're powering. So you have your load here. In our case, we have a capacitor, and I don't know how that represents itself to the power supply in terms of the amount of resistance, but it is a load on your power supply, and this does apply. And I kind of thought this was true, but I wasn't sure, because I filmed this once without looking at this first. I said, you know, I'm not sure if I've got it right, and I want to make sure that I have it right. So here's what they're telling me. Alright, so here's the current flowing through the circuit. This is the minus side. Consider that this isn't a transformer. Consider this is your AC line coming in. Ignore the transformer. And so on this side there's going to be a negative voltage here. It goes through the resistor, and now because of the way that resistances work when they're dropping a voltage across themselves, this will be measured as a positive voltage. Now you go up here, and this is the plate, this is the cathode, and even though they show this being positive, this is your plate, that's the AC voltage that you're seeing here that is positive here. And that's what they're showing here. Now, you actually have AC voltage on here and you have DC voltage showing up. I'm going to show you that in a moment with my meter and with my oscilloscope. In fact, let's do that. Alright, so over here, hiding in the background, is my oscilloscope. The blue line you see here is connected to the plate. The yellow line is connected to my cathode right here. It's on this first capacitor. And then my common is here on the B minus common, whatever you want to call it. Now, the question I was asking myself, is this actually DC or is it just pulsating AC? My oscilloscope, at one point it told me that this was set to DC. So this believes that this is DC. Well, let's find out. There's my meter. And remember that we are connected between common, which is here. Maybe I'll zoom in a little bit so you can see better. Alright, so we're connected. This is our common. Pin 7 is our cathode, and pin 5 is our plate. So what I want to, first of all, I want to go to AC actually. And so we can measure, well, let's just measure between these two and see what it tells me. Alright. So this is AC, and between the cathode and the plate I'm reading 109 volts. Now if I go over here to this and I read this, see what I got? So when I do that, I'm reading directly across here. And you notice when I measured across here, I actually had 100 and whatever it was, 109 volts, whatever. I saw it and I already forgot. So I've got AC volts across this, and that's quite clear. Obviously the current is flowing. I've got my full AC here. It's traveling through here, and the action of the capacitor as a load is probably affecting, well, we just saw that there. So some of the voltage is being dropped across here, which is why we see a positive here, and then some of the voltage is being dropped across the tube. Now when I measured though from here to here, that 3 volts AC that we saw is represented by this. The sawtooth is showing me that I don't have completely smooth DC at this point. But when I measure, let me go to DC now, and I'm going to measure from my common, or B plus, or B minus rather, over here, and I have 114 volts. Now realize I've got my positive lead on the cathode of the tube, and I've got the other lead connected to common or B minus. And I'm reading a positive. If I reverse my meter, you can see it goes negative. And let's swing this around. Now you can see that this is negative 114 volts. That is actually DC volts there. And the polarity, again going from cathode, or from or B minus to cathode, that is a positive 113 volts there. Now, someone had made the comment, and I wish I could find, I went looking for this again. They made the comment, well, what's really happening is, and it was a nice thought, I just don't know if it's, I don't believe it's accurate. At least not according to the naval thing. But what they were saying is, when this goes positive, it pulls the electrons away from the cathode, making this more positive. And while that is true, I don't believe that is sufficient to explain why we're getting what we are here. So again, we've got this voltage going across the load. You put your meter from here to here, you have a minus voltage and a plus voltage. And since you have a positive voltage here, and this capacitor is oriented with the positive end and the negative end here, positive end here, this capacitor is going to start charging as long as that positive voltage that it's seeing is there. And then when the AC sine wave goes negative, this will discharge and start feeding the B+. And because the AC changes state so quickly, this capacitor doesn't have time to fully charge. Although, trust me, if you didn't have a bleed down resistor and you were to disconnect the power and check this, you'd have around 100 volts on this. So don't believe that it's not got enough voltage on there. It will have. And then if you go to this one, you will see, I don't know, well, you'll see that it smooths out quite a bit. I used my analog meter when I was playing with this, and if you moved it from here using the settings that you used to read this correctly, and you move it here, you get a straight line on your oscilloscope, on the analog anyway. And then if you adjust your voltage per division down to the millivolts, then you see the little bumps in the scan that shows you that while it's a whole lot cleaner than it was here, there's still a little bit of it's not entirely clean. It's not completely clean. But since you're talking millivolts, it's good enough for this radio. If you had something that wanted really clean power, this is not what you would use. So I can't believe I spent all this time, and the answer was in the documentation I already had in my hand. And as you can see, this is behaving as a resistor, and the load, the radio, is behaving as a resistor, and it is indeed behaving the way I expected it to, and that means that this is indeed plus right here. And it's kind of weird because this is plus AC, well, this is AC here, and the positive going pulses produce the current. Measure from here to here, this is also plus, but that kind of makes sense because this is plus. It's rather intriguing. Still baffles me a little bit how this all works, but that is the reality, that this is what happens. So ignore the fact that this is a transformer. I believe the same thing is true if you're hooked directly to an AC cord. I believe that is indeed still the reality. Because the same thing is happening. You've got the current flowing through this circuit, just like that, just as I was showing here. And here's the other interesting part of all this. Which orientation do you use? Well, this is positive AC, which should mean that this is the diode symbol that you would use for this. The only problem is that if you have plus here, current's flowing this way through the diode. Oh, okay, so it should flow up this way. It should be this one. Not exactly. This being plus, and if this were plus, the current would want to go that way. But the current can't flow backward through the tube. If this is plus, and this is plus, it's not going anywhere. If this is minus, this tube is still not going to conduct because it's going to want to pull the electrons that are being provided by the heater. Electrons are negative. So the only way you're going to have current flowing through this tube is if this is plus and there are electrons available here to travel to this positive charge. This is why your tube doesn't work if your heater goes kaput. No heat, no electrons, no current. So, which one of these is correct? Neither one of them. Neither one of them match what is actually happening here. This is behaving like a diode, but it's not behaving like either one of those. It's kind of a unique situation. At least that's my conclusion on this. So, yeah, so that's what I've come up with, and I believe I'm right about this. I'm really glad. I was going to post something, but I hadn't reviewed my old video. I was being lazy, I guess. I thought I remembered. I didn't. I'm glad I went back and I reviewed what I had done, and this is what I said, oh, I was right when I was thinking about this. Because I remembered my illustration. If you go back to that video, and I'll put a link to it up there. You'll see my experiment with resistors and the power supply, and you'll watch what happens as I measure between here and here and here. We'll call that a resistor. Between here and here and here and here, you'll see what I did. But it's simple. I'm sure you can understand it. You don't necessarily have to go back and look at it. I'm quite sure it's obvious to all of you. If not, like I said, I'll put that link to the other video. So this is different than the full wave because you're not talking about different phases doing different things. But at the same time, you're talking about the same thing because of how voltage being dropped across a resistance works. You measure across a resistor, one side's going to be minus, one side's going to be plus. And it's just fascinating that that's how this works. And is it possible that it helps that this goes more positive when this goes positive? It could. Is that the answer? I don't think it is. I think this is. So, I hope that helps. I've gone round and round on this. I've spent way more time on this than I really thought I was going to. And I'm glad I invested the time. I'm glad I've got now a better understanding because I was puzzled. Because when that guy asked me the question, Jim Smith, I think I said what his name was, I was intrigued by the question. I was also disappointed I didn't have an answer, although the answer I gave him did include this idea. And it turns out that I was right. My memory didn't completely fail me. Whenever my memory works at my age, I'm happy. And apparently it kind of did. So, I hope this answers the question. I hope it makes sense. So it's rather interesting. I'm going to wrap up now. I welcome your comments. I hope that helps answer the question. It makes me happy that I now believe I have a question, or I have the answer. I'm going to shut this all down before I forget. And like I said, I hope it explains it clearly enough. Give me a comment if I need to say more about this. I think I've got it clear, but if there's something that you want to mention to me, I welcome comments always. So, appreciate you watching, and see you on the next one.